Thank you for joining this lesson. We're going to continue with Capsabet High School Pre-Mock Mathematics Paper 2. We've already covered number 1 on quadratic expressions. Let us look at number 2, which is on errors. We are told to calculate the percentage error in the volume of a cylinder whose radius is 8.75 centimeters and its height 3.5 centimeters. Remember to subscribe to this channel and to also share the link with friends. We've already done number 1, so allow me to use the space above. Calculate the percentage error in the volume of the cylinder. All right. The first thing we should do before we get to the errors is to know how the volume of a sphere is obtained. This is through the area of the cross-section multiplied by the length or the height. Area of cross-section times height. Area of the cross-section, which is circular, is pi r squared. Then now we multiply by h of the cylinder. The variables here are only 2. Remember, pi is a constant. Then we have radius and height, which have been recorded as shown. The radius to 2 decimal places. That means for us to get the range of the radius, then we need to take the radius which is provided, 8.75. Because it is in 2 decimal places, then we have to add the absolute error in this recording. When it is 2 decimal places, we usually take 0.01. We divide by 2 for us to get absolute error. That is 0.005. So this is the absolute error in the recording of the radius, which means that the radius will range between when we add or when we subtract the absolute error. This will take us to a radius of the least being 8.745 all the way to the largest value being when we add 8.755 centimeters. So that is the range of the radius. We can go to the range of the height, which is now going to be, because it is to 1 decimal place, then it's 32.5 plus or minus the absolute error in the recording of this height. This is going to be, because of the 1 decimal place, then we will take 0.1 divided by 2, giving us 0.05 centimeters as the absolute error. So we add 0 or subtract 0.05. This will take us to 32.55 centimeters. This is the maximum, all the way from 32.45 centimeters, the least possible value of the height. Now we have maximum height, minimum height, we have maximum radius, minimum radius. Now we can go to the volume maximum, which will be given by pi 22/7 multiplied by the maximum radius being 8.755 squared multiplied by maximum height being 32.55. Let me compute this. 22 multiplied by 8.755 squared, then multiplied by 32.55 divided by 7. This gives us 7841.30. 7841.30 cubic centimeters. We can go to volume minimum, whereby we will take pi times the minimum radius being 8.745 squared multiplied by height minimum being 32.45. Then now I compute this. We're going to have 22 multiplied by 8.45 squared multiplied by 32.45 45, then divided by 7. This gives us 7282.03. 7282.03 cubic centimeters. So now we are having maximum and minimum volumes. Allow me to go to what we call the actual volume. Volume actual, or rather the working volume. This is going to be pi times radius squared, which is going to be 8.75. So we pick the radius now, squared as it was recorded, multiplied by height as it was recorded, 32.5 centimeters. So this is going to give us a value, 22 multiplied by 8.75 squared multiplied by 32.5. Then we divide by 7. This is going to be 7820.31. These are cubic centimeters. Now with volume maximum, volume minimum, and actual volume, then we can talk about the absolute error. The absolute error, whereby we need volume maximum 7841.30 minus volume minimum 7282.30, or 03, that is, divide by 2. So this is going to give us, when we take 7841.30 minus 7282.03, then we divide by 2. This is going to give us 279.635. That is the absolute error. There's something else called relative error in the calculation of the volume. So for us to get percentage error, now we need relative error, and relative error is given by the absolute error divided by the actual volume, 7820.31. Now this one is giving us what we call the absolute error. When we take the relative error, the relative error is given by the absolute error we have divided by actual volume. And for us now to get percentage error, then we multiply this by 100%. Therefore now we're going to get the percentage error by multiplying the relative error, which is already here. Relative error is absolute error out of working volume. Then we multiply by 100%. So I'm going to divide this by 7820.31. Then I multiply by 100. This gives me 3.576. 3.576%.